Yeah, question 11. Here you've got numbered cards here, 5 cards, number 2, 3, 4, 5, 6. Cards are shuffled, 2 cards are chosen at random. Calculate the probability the numbers on the cards chosen are both even. Okay, so in other words, first one's even, second one's even. Okay, that's it, they both got to be even. So, probability of the first one being even, well, this is even, isn't it? That ticks the box, that one's even, that one's even. So you've got 3 chances, haven't you, out of 5, okay, for the first one to be even. 3 chances out of 5. And then of course, because that one's been even, you've got 1 less card in there now. You've only got 4 cards, haven't you? And also you've only got 2 evens that are left, okay, because one's been taken out. So then you've got this, multiply the top, so you get 6, multiply the bottom, 20, so 6 out of 20, and leave it like that, no need to simplify. Part B, then calculate the probability that the product of the numbers on the chosen cards is odd. Now product means multiplying, right? That's what that means. Okay, times in, that's what product means. So the 2 cards that come out have to be, the product of them is odd. And the only way that could happen is if they're both odd, okay? That's the only way you could get, the product to be odd. So they're both odd. Right, that's the only way, because if one of them was even, then a product would produce an even answer, because we multiply it and then 2 numbers together and one of them's even, okay, or both of them even. But if there's one even number in there, it doesn't matter what else you multiply by, even times an odd, it'll come out as even. The only way you multiply numbers together comes out as odd is if they're both odd. So the odds here you've got 2 that are odd, haven't you? So you've got 2 chances out of 5 times then the second one. Well, if an odd one's already been taken out, you've only got 1 odd left out of 4. So that comes to be 2, isn't it? 2 out of 20. 2 chances out of 20. Okay, that's all it is, 2 out of 20. There's another way of doing this. You could just list all the possibilities. Okay, it takes a bit longer, but you can be assured of the answer there. So you could look 2, 3, 4, 5, 6, like a sample space. 2, 3, 4, 5, 6, okay? And you basically put down all the possibilities there are, okay? So, so if we go here, look about 2, and there, 2. You can't have that if you think about it. They both can't be 2, can't they? So we'd have to ignore that one, okay? And the same here, you can't have both of them being 3, can't have both of them being 4, can't have both of them being 5, can't have both of them being 6, okay? But you can have this here, where you have 3 and 2, okay? So 3 on the first pick, and then 2 on the second pick, so times them you get 6. Then you've got 4 on the first pick, 2 on the second pick, so that's 8. 5 and 2 is 10, 12. Times these then, so you could have 2 on the first pick, 3 on the second pick, so 6. Keep going like this, 12, 15, what's that, 18. So then you've got 8, 12, the 20, 24, 10, 15, 20, 30, 12, then 18, 24, 30, okay? And the only ones that are odd are here, okay? There's 2 of them, and how many possibilities are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 2 out of 20, exactly what I got up there. Okay, part C then, calculate the probability that at least 1 even card is selected. Okay, so 1 even card, well, it could be both even, couldn't it? Or one of them even, the other one odd, or one of them odd, one of them even. So this situation we know already. We did at the top, that came out to be 6 over 20. Or then we can add these together. So the first one being even, you've got 3 chances out of 5. Times then the second one being odd, well, you've still got 2 odd ones there, 2 chances out of 4. Add then, well, the first one then, in this situation, first one being odd, you've got 2 chances out of 5. And then the second one being even, you've still got 3 evens out of 4. So this is 6 20ths, plus then 6 20ths, plus then 6 20ths. So you've got 18 20ths. 18 out of 20 chances of one being even.